Okay, so there's our first one. So 5.2, compound interest, $10,000 is invested at 5% interest. Find the amount of money in the account for 7 years. The interest is compounded annually. Okay, let me just give you a compound interest formula to help out with this. So the amount from compound interest is P1 plus, oh wait, that was simple interest. I'm getting confused. There we go. P plus R over N to the NT. So you can put that right on your 3x5 card for the next exam. I think you know what most of those players is. N is the only confusing thing. N is the number of compoundings per year. Number of compoundings per year. T is the number of years. Okay, let's give it a try. So 10,000 is invested. Where do I put that 10,000? Yeah, that's the P, huh? So 10,000. And interest rate, 5%. What do I do with that? 0.05, N for R. N, what's N?
12. Number of months.
Interest is compounded annually. So what does that mean? How many times a year? Once. So N is 1, right? Number of times per year, N is 1. 1 to the 1, use N twice, right? N is here and it's here. Times T, and what is T? 7 years. There we go. I don't know if you can read all that. Like that. So in our calculator, it would be 10,000, 1 plus 0.05 to the 7, won't it? So just take that, hit the buttons on your calculator. Let's see what we get. So we'll want to have your calculator with you. We'll do a lot of calculations, especially this section today and Thursday. Tons of calculations. You want to definitely bring your graphing calculator with you to class. I'll be showing you some ways to make these things easier. They get a little hairy. We're doing calculator intensive stuff. So 14,071.00. Y'all getting that? So that means, what does that mean? That means that $10,000 will grow and become $14,071 in 7 years at 5% interest compounded annually. It grows. Is that good? Is that making sense? So if you're having trouble on that, let me know. You guys getting that on your calculator? Make sure you can get that. If you're not, grab me. There we go. Yeah, so try that with 18,000. Let me write the formula again. A equals P 1 plus R over N to the NT. Try that one. 18,000 at 4% compounded what's semi-annually?
2 times a year.
2 times a year, right? Every like a semicircle is half a circle. Semi-annual is every half a year. So twice a year, right? So they're compounding the money twice a year. Halfway through and then at the end of the year. Semi-annual. So that means N is 2, doesn't it? So try that one. Give you a second. See if you can get a number on that one. All right, let's try it out. So we're going to plug in 18,000, 1 plus R. The interest rate is 0.04 over N, which is 2 to the 2 times 5. So 18,000 times 1 plus 0.04 over 2 to 10. I'm going to figure out, yeah, that power just becomes 10, doesn't it? So there we go. So 18, 1, 2, 3 times. I'm getting 21,941.90. Did y'all get that? Is that okay? Anything I can help with on that? Y'all have your graphing calculators with you? Able to crank those out? Coming out okay? I can't do a natural display, able to get that thing too? You can almost do it itself without you even hitting the button. All right, we good? No questions? All right, I'll move. All right, let's try that one. So $3,000 put in there at, well, can you read that? All right, there we go. So $3,000 at 5% for 3 years. And it's compounded semi-annually. So A equals P, 1 plus R over N to the NT. So the principal is 3,000. The interest rate is 5% over N. What's for semi-annually? What's N? 2. N is 2. 2 times a year, huh? And the time is 3 years. So try that. See what you get. I'm getting 347909. Oh yeah, it's right there. Huh. I got 09. Why'd they say 08? Oh, I can't see. It is 08. Yes, it is 08. That's right. All right, so we get to that. Now the second question is earned interest. Well, how do we find the interest earned? Just subtract, right? Right, because the original 3,000 grew and became 3,479.08, and they're saying how much interest was earned. Well, that would be the subtraction, right? 3,479.08 minus the original 3,000. The interest earned was 479.08. They're just saying, hey, how much did it grow by? What was the interest? All is well. I'll move on, if you're good. Number 5. Onward and upward. Okay. So a gift of $6,000 grew to a city, grew to $7,200,000. That's like, Benjamin Franklin leaves the city of Philadelphia $6,000 in, 1818. How much is it now in the year 2017, 200 years later? Well, compound interest grows pretty substantially. So the formula is A is P, 1 plus R over N to the NT. So, where do I put the 6,000? That's the P, that's the principal, that's how much was first invested. Good. Where do I put the 7 million? Yeah, that's the amount that it turned into after 200 years. It grew to become $7 million. The time value of money. So you just got to put your money in the bank and wait for a couple hundred years. And the rate, that's what we're trying to find. We don't know what R is. What's the N? Yeah, compounded annually. Annually is just once a year. Remember, N is the number. So if N is monthly, if they say compounding monthly, the N would be 12. So I'm just making sure you're okay with N. So how many times a year? So they say annually. And what if they say quarterly? The money is compounded quarterly. What is N? 4. That'd be 4 times a year, right? N is the number of compoundings per year. So N is 1 here. And what is T? 200 years. So there's our little equation. Let me bring it down here. So 7 million equals 6,000. 1 plus R to the 200. R over 1 is just R, and 1 times 200 is just 200. Good? To there. Now, how do I solve that for R? Got to get R alone. Yeah, how do I get R alone? Here's the wall. R saying, I want to be alone. Get rid of all this stuff.
Minus the
What should I do first with that 6,000? Is it added? Divide it. Divide it, right? Because it's times. It's up against those parentheses, so it's times. So the opposite of times is divide, right? So divide by the 6,000 on both sides. Bring it over here. So it's probably ugly, huh? 7 million divided by 6. Yeah, it's something ugly. I'm just going to leave it because you don't want to round in the middle of a problem. So I'll just leave it because I did my calculator and it came out some ugly decimal. So 1 plus r to the 200. Good to there so far? Now what am I going to do? I'm trying to get r alone. Okay, now remember, it's like solving for something, getting something alone, r alone, is like peeling an onion. What I mean is outer layers come on down to the inside. So I need to do the outermost layer next. What's the outermost layer on the right side here? Looking at this, r said I won't be alone. So what's the outermost layer? The 200. That's outside the reason. I should be thinking about getting rid of that 200 next, not the 1. The 1 will come at the end. So you go outside all the way to the inside. So get rid of that 200. How do you get rid of that 200 power thing? Yeah, we did it in the last exam. Yeah, no, yeah, good. Yeah, why don't I do ln? Should I do ln? No, when's ln? It's close, not quite. When's ln? How's it different when you use ln or log, either one? When do you do that, and when do you do the 1 over 2? How do you know which is which?
There's an exponent in the power. You log.
Wait, you're almost saying the right thing. You just said if there's an exponent in the power, that means there's a power in the power. Exponent means power. You mean if there's a
variable in that.
There it is. If there's a letter, remember I did Hitler climbed in the power, tried to help you remember. If the letters, not just if there are powers that you need logs. I'm talking about when you need ln. You need ln when the letter gets in the power zone. We just have a number. So we can just do the 1 over 200 here. We don't need ln. Does that make sense? You need ln when the letter gets into power, right? That variable, Hitler climbs into power. That's when you need ln. So we can just use 1 over 200 power on both sides, canceling that out. So 1 plus r is 7 million over 6,000 to the 1 over 200 power. And that gets rid of the 200 power thing, and so last step is just subtract 1, huh? Just subtract 1 from both sides. So hit the buttons on your calculator. It's 7 million over 6,000 parentheses to the 1 over 200 power minus 1. I'm getting point, I can see in the dark here, 0.359 hundredths. Okay, 0.3594. 0.3594. Y'all getting that? Oh, can't even read it there, huh? Move it up. Oh, 0.3594. You able to get that on your calculator? This is what I want you to be able to practice on your graphing calculator and see if you can get those. You having trouble? Let me go around and help for a bit. Make sure you're able to get that. Is that good? Anybody I can help? You okay? Good. Making sense. You guys okay over here? That's a very famous point that you had. We're working out okay on that? Okay. If you have trouble with anything, I'd be glad to try to get you some help. YouTube's come out office hours, or people at the tutoring center might know too. That's just like a little computer, so advanced.
I got a negative. Is it?
Negative, let's see what you typed in.
Because I put the 1 minus.
Oh yeah, you gotta put the one at the back.
Oh, okay.
Yeah, it doesn't matter. Same answer. Yeah, the order of subtraction matters. Right, think about numbers. 5 minus 2 is not the same as 2 minus 5, right? It's 3 one way, it's negative 3 the other.
Oh, okay.
So the order of subtraction matters. Is okay? You all right? Does everybody have, it reminds me, Does everybody have one of these? Because in about a month, it's like if you have that 89, that's super powerful. But I'm going to give a program that only works on the 84. I'm going to come by and infect each of your calculators. I'm going to hook up a wire and give you a program to do something we're going to do in about a month. So I don't have the program for the 89. I don't have the program for the Casios. I think there is something online. It's pretty difficult to try to get it. So anyway, these are. I don't know if they're still at the library or not. Miss Curtis has them down in S1. She's down the hall over there, S1. I would pick one up from her. Make sure you have. If you don't have a TI-84, then get one. I've heard she still has some. So definitely get one before, about 3 weeks or a month from now. We're going to really need it with a special program. All right, anyway, we got the R there. We all good? Questions on that? Can I move on? We good? So when do you use LN? When the letter climbs into the power zone. Hitler in power, right? Matters not just that there are powers, but who's in power. If the letter's in power, we use LN. If it's just numbers in power, then we just do one over the number on both sides. Yeah. Okay. APY, annual percentage yield. APY, annual percentage yield. That's what that stands for. They also call it, I forget what they also call it. It's something like the real rate. What is it? I don't know. Anyway, I'll come to me later. Anyway, annual percentage yield, APY. What that means is what's actually happened. This means actual percent money will grow in 1 year. Annual, that means once a year. Percent yield, what it'll yield, what it'll produce in 1 year. Now, what we're talking about here, you might say, well, isn't that 3%? That's the percent. Well, the trick is that's 3% is not a true 3%. It's 3% compounded semi-annually, meaning compounded twice a year, right? Semi-annually is twice a year. Think with me before I give you the formula and show you, you do this, do that, do the other thing, I will. But more important in life, like going into business and stuff, this is something they use all the time. In fact, there's laws, federal laws now that they have to tell you APY, annual percentage yield, on a loan or anything deal with money. They got to tell you what it's really going to do. So let me give you a feel for what it really is. Why isn't it just 3%? Well, because 3% is done twice a year. It's not. That's right. It's semi-annual. It's twice a year. So it's not. They're saying APY is what it'll do once a year, in 1 year. What it'll do. Well, okay. Think with me. Do you know what happens when they say we're going to compound your money 3% semi-annually? What does that mean? Like if I have $100 and I say I'm going to go put $100 in the bank, and they tell me they're going to compound it at 3% semi-annually. Did you know that means halfway through the year they're going to compound my money, and then at the end of the year they're going to compound my money, right? But it doesn't mean that they're going to do 3% both times. It means they're going to do 3% total. So it's 1.5% the first time and 1.5% the second time. Does that make sense? So when they tell you 3%, that's an annual rate, meaning for the whole year it'll be 3%. So they say we're going to do 3% by doing it twice a year. That means 1.5, 1.5. You making sense with me? So if I say, hey, they're going to pay you, you've got it. So 3% done twice a year means they're going to give me 1.5% 2 times, because that's 3%, right? 1.5 times 2 is 3%. That's what they really mean when they say they're going to do that in the real world. Okay, so what does that mean will happen to my money? That means halfway through the year, they'll take your $100 and they'll give you 1.5% more money on it. Okay, let's change that to a decimal. You know what to do. Move the decimal back 2 places, 0.015. Multiply on your calculator, it'll be $1.50. They'll give you $1.50 halfway through the year. That's 1.5% of $100. Good so far? Give you $1.50 halfway through the year. And then that's at the end of 6 months. And then at the end of the year, they'll give you another 1.5%. Which seems like, at first, without more careful thought, it feels like, well, so they'll just give you another $1.50. It's the same interest rate, just another $1.50. So $3. Why didn't you just say 3%? I mean, it's $3, whatever. No, it's not quite. They won't. It's not $1.50. What's different? What's wrong about that?
You add the 150.
You're gonna have
Yeah. Excuse me. Excuse me again. So yeah, they take this 150 that you got halfway through the year, and they say, oh, now you've got, you don't just have $100 in the account. Starting halfway through the year, they compound that. That means interest on interest. Notice they say, that $1.50 that you earned halfway through the year of interest, that's now yours. That's now in your account. So starting at halfway, you now have not $100, but $101.50. I added that $1.50 to my original 100. So now they'll take that and compound that. So that's interest on interest. That's called compounding, one on top of the other, right? Or like if you compound the problem, you mean you make the problem on top of a problem, right? This is compound interest, interest on top of interest. Get the idea? That the last section we just did simple interest, which just means if this was 3% simple, they would just give you 3%. Period. Nothing fancy. End of the year, 3%. There you go. Done. Simple. But this is not simple. This is compound, like compounding a problem, problem on a problem, compounding interest, interest on interest. So they'll pay you 1.5% interest on the interest. So what's that going to be? We'll take a calculator because I can't do it by hand. I'm going to get $1.52. So it's not a lot different. In fact, it's only 2 cents difference. It's 2 shiny pennies. They'll give you $1.52 because it's a little bit. So it's not gigantic. It's a little bit of interest. So add that up. Altogether for the year, you'll get $3.02, won't you? In interest. Get $1.50 halfway through the year. Get $1.52 at the end because it's interest on interest. It's a little more. So in the end, when all is said and done, really at the end of the year, that 3% actually pays you slightly better than 3%. 3% straight would have just been $3. They're paying you $3 and 2 shiny pennies. So really, what's the real effect? What really happens to your money after a year? They pay you 3.02%. Really, the APY is 3.02%. It's not so 3% done twice a year. The real effect, well, that's what it's called, effective rate. That's the other term. The real effect, the effective rate, the APY, the annual percentage yield, what your money really yields, is 3.02%. It's a little better than 3%. It's a little higher. The APY is always higher. That's what they have to tell you by law on any loan or any money situation. If they say the rates this way, the terms this way, whatever, blah, 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 what's the effect at the end of the year? That's called the APY. So that means every dollar is going to give you 3.02% on it, really. That's the real effect. Does that make sense? So when you compound interest on interest, it's more than meets the eye. It's not just 3%. It's a little better than 3%. Okay. Now, how do we find that? I just did a fancy rigmarole to find it. We don't want to do that every time. How do you actually find annual percentage yield? Well, let me give you a game plan. I think I'm a little different than what Math Excel says here. My ways I try is a little bit easier, I think. To find APY, annual percentage yield, number 1, put in $1 for 1 year. Here's my philosophy on annual percentage yield. If you can find what happens to $1 after 1 year, you can find what happens to every dollar. You can find the percentage effect. So just put in $1 to the same old normal formula. I mean the same one we've been using. We're not using a new formula here. 1 plus R over N to the NT. Same formula. Just put in $1. That's your P. For 1 year, that's your T. And they're giving you the rate, 3%. Put in $1 for 1 year. Take the answer you get. Take the answer minus the original dollar. Because you put in $1, so you got to take your answer and subtract. That's a subtraction there. Subtract the original dollar back out and change. Step 3. Change to percentage. So there's the 3 steps. Let's do it. So I come over here. I use the same formula. Whenever they ask you for annual percentage yield, you go, okay, I'm going to put in the principal of $1. The interest rate, 0.03. What's the N? Number of compoundings per year. Semi-annually? 2. And what's the T? What's the time? 1 year. That's what I'm saying. $1 for 1 year. Everybody see how I put in 1 for P, 1 for T. $1, 1 year. Put in $1 for 1 year. Hit the buttons on your calculator. I'm getting 1.030225. Good there. So that's what happened to that dollar. That $1 became $1.030225. So far, so good. You with me? That's step 1. Step 2 says subtract that original dollar because we just want to know the growth. We want to get rid of that original. So you just cut off that dollar from the front. Is that good? So it grew by 0.030225. That's the decimal. Final step, change that to a percentage. How do you change that decimal back to a percentage? 2 places, bonk, bonk. So 3.0225%. See, that's what we said a minute ago, right? 3.02%. This is just more exact. 3.0225. How far do they want? Hundredth. Hundredth is right there. So 3.02%. That's the answer I got a minute ago with the 100 in the other way. I'm just showing you this is the way we'll do it every time. So sure enough, it's a 3.02% actual yield. That's what really happens to every dollar. Every dollar will grow by 3.02%. Not just 3%. The actual effect of 3% done twice a year is 3.02. The more frequently you compound, the higher the effect really is. So if we did 3% like 4 times a year, or every month, or how about every week, or every day, it would be a little bit higher. But not a lot. I mean, it'd be like 3.03 or 3.04. It's not gigantic, but it would grow a little higher. Is that making sense? So the percentage is affected by how much you compound it. It changes the actual result, the yield. All right, questions? I'm going to move on. All right, so same formula. A equals P, 1 plus R over N to the NT. So present value, the following future amount. So where does that 200,000 go? Yeah, that's the A. That's the future amount, isn't it? That's the A. Do I know the P? Don't know the P, right? Do I know the R? 6%, so what did I say, 0.06? Quarterly. 4, N is 4, huh? Quarterly is 4 times a year. And time, 25 years. Now, what do they want me to do here? They want me to solve for P, don't they? Find the present value. So how do you solve that equation for P? Just divide it, exactly. Just divide by that whole 1 plus 0.06 over 4. I was going to make this 100, right? This 4 times 25 is 100. To the 100 like that. Just divide both sides of the equation by 1 plus 0.06 over 4 to the 100 power. Boom. Good. And so we get P equals something. I'm getting 45,125. 88, so rounds to 89. Y'all getting that? Try cranking it out. Can you see okay? This is what everybody likes with the light in the front, and you guys can see okay with your calculator?
I got 45.125, not like 45,000.
Let's see. Oh, it's 200,000.
Oh, that's what, okay.
So just 3 more zeros. We don't have to do this. That's all it is. Not good? Making sense on that? Able to get that? Anything I can help with? There's few enough of you here. I'm glad to bounce around. My pre-calc classes have 50, so it's kind of got to just stay after class. But there's few of us in here. I can bounce around. Is that good? You guys doing okay on that? All right. So stop and think about that for a second. $45,000 invested becomes $200,000 in 25 years. I mean, that as well. But that's like retirement, right? You know, you start work 25 years later, you retire. Or even, you know, that's actually only half a retirement, actually. So, yeah, if you're 25, if you're like 35, or 40, even if you're 40. Yeah, 40 or younger, if you stick $45,000 in the bank at retirement, 65, 25 years later, that'll turn into $200,000. That's only a 6% account. I mean, you can get 6%. The stock market, the money markets, or the mutual funds are usually around, usually around that rate or even slightly better. So you can get that. That's pretty impressive growth, isn't it? 45,000 turns into 200,000. Something to think about, the time value of money. I'm not an investment guru, and by the way, here's my stock company. No, this is not a personal thing. I'm just kind of amazing, huh? How the money goes up like that over time. But you got to give it a few years like that. Einstein called compound interest the seventh wonder of the world. You know, they pay interest on interest. That's an impressive result there, huh? That's what makes it get so big like that. Interest on interest. 45,000 becomes 200,000 in 25 years. Got to start investing when you're younger, though. I'm too old, so it's a speech for you guys. Got to start when you're like 40 or under. I'm over. All right. They don't really, they say it's a $100,000 prize. Well, they don't just give you $100,000 straight off. They give you $10,000 a year for 10 years or things like that, which is actually way less money. Let's see it here. We'll see the time value of money, right? Because money today is worth more than money later because you could invest it today and it will grow to be more later. Does that make sense? The time value of money? If you want to know what money's worth today compared to later, it's whatever you could invest it today and have it grow to be later. That's what it's really worth. So, as the prize in a contest, you're offered $29,000 now, right now, or $43,800 in 7 years. If you could invest the money at 5%, which one's better? Well, okay, that means we've got to use the same formula. A equals P, 1 plus R over N to the NT. So we want to say, okay, let's put in our 20, let's take the 29,000 and invest it, put it in as a principal investment. The interest rate, they said, is 5%, so 0.05, compounded annually. What's annually mean?
Once a year.
N is 1, once a year. And we're saying 7 years, right? 7 years. So let's try that. .05 to the 7. I'm getting, it would become 40,805. Is that right? 805.91. You guys getting that? So that means the 29,000 today is the same as 40,000 7 years from now. So which one's better? Well, the 43,000 is better because that's still more 7 years from now. Is that good on that? Questions I can answer? So I just put it in the investment formula. Okay, so basically it's 4.75% compounded quarterly. quarterly, versus the other one is looks like it's lower, but it's compounded monthly. It's compounded a little more frequently, so it's going to make it grow a little bit more. So basically, we just have to figure out the APY. We don't care about the 18-year. That has nothing to do with it. Remember what we do for APY, annual percentage yield? You put in $1 for 1 year. So put in $1 for, so take each of those one at a time and do the normal same formula. P1 plus R over N to the NT. So the amount will be, put in $1 for the principal. The interest rate, 0.0475. Quarterly is 4 times a year for 1 year. Everybody see how I came up with that stuff? So same formula. Let me open this up. Get a little stuffy in here. I'd open the windows, but we're in the basement. Is that good? See what I'm doing there? So I took the same formula we've been using. I did the interest, the 4.75%, 0.0475, quarterly, 4 times a year, and it's for 1 year. $1 for P, 1 year for T. That's what you do for APY. You guys getting the hang? That's how you compare two rates that seem totally different. Like, how do you know which one's really better? You find out exactly what they do in 1 year. And then you know. That's why APY is so important. That's how you can compare things. So crank that one out. Let's see what you get. $1.04835. The other one, try the other one now. $1, 1 year, 0.0474 monthly. So N is 12, huh? I'm getting, wait, I did something wrong. Oh. $1.04844. It wants me to do the annual percentage yield to 3 decimal places. So remember what we do for annual percentage yield. We cut off the 1 in the front, right? Because you subtract back out the original dollar so you can get the growth. And then you move the decimal 2 places to turn it back into a percentage, 4.835%. This one, same thing. Move it 2 places. Cut out the 1. Move it 2 places. 4.844%. So there's the APY for those two. So the second one's better, isn't it? The second one has a little bit higher effect. Not a lot, but a little. What's that? Yeah, because it's more frequent. Even though it's lower, 4.74 is lower than 4.75, it's done more frequently. It's done more often. So that makes the money actually grow. Really, in the end, they're paying you 4.844%. That's what they're really going to do to your money in a year. And the other account really is 4.835. They're both higher than their listed rate. They're both higher than original listed, but the second one climbs even more. Everybody see that? See how annual percentage yield works? It's the real effect on your money in a year. You know who this is a crazy calculation for is those same day cash, fast cash places all around town. Same day loan and whatever they call it. They go by all those different names. Fast cash, same day loan, paycheck, payday, all those places. Those places should be outlawed. In fact, They are outlawed in, I think, 17 states. I'll have to go on Google before I'll bring you the some information on Thursday. I think it's very interesting. You know, California is like one of, like I said, 17 states. Those places are illegal. They kill people basically on their paychecks. They're taking a percentage, but it doesn't sound like if you go in. I've never been in, but I've read about them. They basically say, oh, it's just, you know, if you're running low on money, bring us the proof of your employment and your paycheck, and a week in advance, you're running low, you're not quite making it to the end of the month, week in advance, we'll give you your paycheck, basically a week ahead of time. We'll just take a small percentage out, and we'll give you your paycheck a week before you get it, so you can make it to the end of the month. We'll only take, I don't know what, 10% or whatever, 5%, doesn't sound like that much, but if you realize, say if it's even just 5%, 5% is not that much, right? Well, it's not 5% for a year. They're not giving you the money for you to keep for a year. No, they want to be paid back in 2 weeks. So they're charging you 5% just for 2 weeks. If you turn that into an annual rate, it's crazy. That's why it's outlawed in 17 states. For exorbitant fees. They're charging you like crazy amounts of money as far as an annual, you know, just for 2 weeks. You get the money for 2 weeks and they want payback that quick. They're really killing people, and that's what they do. I had a good friend. That's probably why I have an issue with it. Like 20 years ago, I had a good friend, and he just got into that cycle. Every month, he'd come up, him and his wife, he'd come up a little short, so he'd go down to the payday loan, and they'd give him his paycheck ahead of time, and then guess what would happen the next month? Well, they just took a big chunk of his paycheck, and so the next month, he comes up short again. He goes back to the payday loan, and it's a vicious cycle. And he was just going there every month, basically just handing them a big percentage of his paycheck. Is what you're doing. Those places are preying on the people that are having a little trouble. That's what they're doing. Better to eat noodles for those last 2 weeks and keep your money and get back on track than to have them take advantage of you. I'll bring in the numbers. That's why they're illegal in 17 states or whatever it is. So the APY calculations are crazy. So if you ever go in there, just ask them, hey, what's the APY? They have to tell you. They're embarrassed to tell you that. Or, well, you know, it's kind of high. Yeah, it's crazy. All right, anyway, so there we go. Questions on that? That making sense, the APY? So it means annual percentage yield, what the account's really doing in 1 year, no matter how people try to play with the terms. On inflation here. Okay, yeah, so if inflation is 7.5%, that means every year, you know, prices are going up. You've probably seen prices going up since they raised minimum wage and are raising minimum wage. All the prices are going up on everything. So if inflation is 7.5%, what's that going to do? How long? They're saying how long would it take for prices to double? So if every year, this is annual inflation. So if every year all the prices go up by 7.5%, that's a little high. That's not the normal rate of inflation. What is it? Isn't it like 2.5 or something? Is that what? I forget. I thought maybe. Isn't it usually about 2.5? Is it 2.9 right now? Okay, yeah. I thought that's more like, yeah, this is not what it normally is. But yeah, so if it was at that high rate, at 7.5%, how many years of that until prices double, basically? Well, we're going to use the same formula. A equals P1 plus R over N to the NT. Same formula, the whole section. Okay. Now, this is kind of weird. We know that the R, this is the R, right? 0.075. 7.5%. Move the decimal 2 places, 0.075. Good. What's the N? It's just 1, huh? Because annual. So inflation is compound interest, basically. I don't know if you ever thought about it that way. But however much prices go up 1 year, when they go up the next year, they're going up on what they went up. See how it's interest on interest? It's gain on gain. It's compounding. So it's compounding. So inflation is compound interest, effectively. So, okay, so the N is 1. The annual means once a year, right? We're saying the prices all go up 7.5% in 1 year, 7.5% the next year. So the N is 1, once a year. And number of years, T, that's what we're looking for. We don't know how many years. Well, what do I do for the A and the P? I know I'm going to leave T as T. I'm looking for T. They're asking how many years. But what about the A and the P?
Can you make the P1 and make the A2?
You could. That would work fine. That's a good idea, Joel. Or you could just say the amount is, we want prices to double, right? So if you originally put in P, how much do you want it to be later when it's double that? 2p. That makes sense? Which is the same as what Joel was saying. You can just put in 2 and 1. That'd work fine too. Or you can just put in p and 2p. Either way, the first step is p will divide out of both sides, and we'll be right to where Joel said 2 and 1. That makes sense? So he's right. Eventually, you want the amount to be double whatever the principal was. Right? Whatever the original price was, you want the amount later to be twice that price. Because prices have doubled. So you want to find out what t will make the amount become 2p. So yeah, first step is I'm dividing p out of both sides. So I get 2 equals 1 plus 0.075 to the t. That good to there so far? Everybody happy? Let me bring it up here. I'm going to make that 1.075 to the t, right? Just put that 2 in the front. Put those together. Okay. Good to there? So I just plugged in the interest rate, 7.5%, once a year, it's annual. And the amount, we want the double, so 2p. Divide out the p on both sides. Like Joel said, it's just gone. The p's are gone. So now I got to solve that for t. What am I going to do to solve for t? Yeah, look where t is. Hitler's climbed into power, right? I can give that a little history story to help you remember, right? Churchill got serious when Hitler went around. We get serious too, because we don't want that letter in the power zone. That's just hard to deal with. What brings it down? What dethrones the powers? The army. You need a good army. That's what Churchill used. No, we need natural law in the math world, right? We need natural law. That's like our army. That's going to bring the powers down. LN or regular log. Either one will work fine. You could use regular log or LN. Either one works totally great. I just use LN all the time. That way, if there is an E, it's perfect, and without an E, it's fine too. So you can do regular log though. That'd work fine too. Either one, same thing. Remember, the power drops down. That's the great quality of the log. The power drops down. We get T ln 1.075. So ln 2 like that. See how that dethroned the power? Got Hitler out of power. Hitler's a regular guy now, not dangerous. The T's not in the power zone anymore. So remember so when the letter is in power, ln both sides. So when the letter is in the power, that's different than when we had like that 200 in the power a few problems back, right? We had that 200 in the power, then we just did 1 over 200 on both sides. But if you have a letter in power, you ln both sides, because then the power comes down. So now, why is that so great? Well, because now you can just divide. Now just divide by the ln 1.075. Boom. Hit the buttons on your calculator. I'm getting they want a whole number, 9.58, so we'd say 10 years. That's pretty fast, huh? In 10 years, prices would double. Of course, that's pretty high inflation. That's not what we're experiencing. But in 10 years, rounded, prices would double if inflation was that high of a rate. Is that good? Questions on that?